and welcome to Inner Talks, where we chat with experts about what's currently happening and what's new in the EV battery industry. From tech to trends, ideas and opinion, you can find it all here. Today, we're here with Fergal Harrington-Beatty, the CCO of E-magy, to discuss about challenges and opportunities of adapting silicon-dominant anodes instead of graphite for the next generations of EV battery.
So I think the key thing with silicon is that it has an inherent energy density advantage over graphite. So it has a higher theoretical capacity, which effectively means that it can have a higher energy density than graphite when it's used in a lithium-ion battery cell. So this means that you can have longer range electric vehicles, longer lasting consumer electronics, or faster charging drones. Silicon is also one of the most abundant elements on Earth. So it's the second most abundant element in the Earth's crust. So it's very widely available, especially in the metallurgical form. So I think those are the two of the key reasons really why silicon is taking over graphite. So one of the reasons silicon hasn't been fully adopted today is because the existing silicon technologies are very hard to scale. So silicon anodes like silicon carbon that rely on the silane have been hard to scale because the silane supply chain outside of China is very limited. So silane came from the solar industry and was used to make solar panels, but it has since been sort of dropped in the West. So there's very limited silane production both in the US and Europe. And this means that the silane that is available for making lithium-ion battery material is very few and far between. So which makes it quite expensive and then also creates a very sort of tight supply chain for silane-based technologies. Then when looking at silicon dominant systems that use CVD, which stands for chemical vapor deposition, these technologies are also hard to scale because the manufacturing process at the moment is very slow and very expensive. So it's only able to make material at the megawatt hour level compared to other more scalable technologies like we have at E-magy. So at E-magy, we make a nanoporous silicon anode material in the Netherlands. So we use a metallurgical silicon as a feedstock, which is widely available and easy to source anywhere in the world. And we also have a process that gives it a nanoporous structure, which helps reduce the expansion of the silicon when the battery is charged and discharged. So silicon dominant anodes are already on the market today, primarily in drones and consumer electronics. These are good entry markets for silicon anodes as a new high energy density battery technology. So drones have particular requirements where they need both high C rate for the takeoff and landing, but also high energy density so they can travel as far as possible and carry as heavy a weight as possible, which makes lithium-ion batteries using silicon anodes a particularly good technology. Consumer electronics are also a good market because they have very high requirements for energy density. So for smartwatches, mobile phones, and tablets, even next generation products like smart glasses that also utilize AI, there is a lot of demand for much higher energy density batteries for these products, which is why we see silicon dominant anodes getting into the market there today. Yeah, so silicon is already used today to a small amount. So in premium electric vehicles that have high energy density batteries like Tesla, for example, or Porsche or Lucid, there's already a degree of silicon adoption, but this is only in small amounts where silicon is blended with the graphite, so around 5 or 10%. We are seeing that we expect wider adoption of silicon up to 20 to 40%, again in high performance electric vehicles over the next 2 years, so up to 2027. And then think that silicon dominant, so more than 50% or even more than 80%, like our material, we expect this to come in from 2028. So what we're talking about is that there is a first generation silicon graphite. We expect silicon carbon to come in up to 2027, and then we think third generation silicon like ours to come in from 2028. We also see promise in our material coming into solid state applications. So we're seeing a lot of interest from the battery market in using a silicon anode instead of a lithium metal anode. And this technology could also come in around 28, 29.
Thank you for watching episode 5 of the Inner Talk series. Do you have any question for Fergal? Feel free to drop a comment down below or send us a DM. Stay tuned for episode 6.